For this video, we'll discuss how to find the derivative of a function using the limit process. Let's say we have a function f of x. The derivative of a function will be written as f prime of x, and it should be equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. And this will be the formula we're going to use to find the derivative of a function using the limit definition. What is f of x plus h? Let's say we have a function f of x equals x. F of x plus h means that we will substitute the term x plus h to the variable x in the function. In this case, f of x plus h equals x plus h. Now let's plug in our values to the formula. F prime of x is equal to the limit as h approaches 0. The value of f of x plus h is x plus h minus the function f of x, which is x divided by h. Notice that x minus x is 0, so this will cancel out. The remaining term on the top will be h. Now h divided by h is equal to 1. Remember that the limit of a constant function is equal to the constant. Thus the limit as h approaches 0 of 1 will be 1, and that is the derivative of x. Let's take another function. Say f of x equals x squared. How can we solve for its derivative? First, we need to find f of x plus h by replacing the variable x with the term x plus h. F of x plus h will be equal to x plus h squared. We know that the square of x plus h is equal to x plus h times x plus h. Let's apply the FOIL method to find the binomial expansion. X times x is x squared plus x times h is hx plus we have h times x is hx and h times h is h squared. Now we have f of x plus h is equal to x squared plus these two hx terms will add up to 2hx plus h squared. Let's plug in the values to the formula. The limit as h approaches 0 of f of x plus h, which is x squared plus 2hx plus h squared, minus f of x, which is x squared all over h. X squared minus x squared will add up to 0, so we'll cancel this out. Now we can factor out h in the numerator. Thus, we have the limit as h approaches 0 of h multiplied by 2hx divided by h is 2x plus h squared divided by h is h all over h. H divided by h is 1, so we can cancel these values. To find the limit, we will substitute the value 0 to the variable h. Now 2x plus 0 is 2x. Therefore, this is the derivative of x squared. Let's have another example. How about we find the derivative of a function inside the radical sign? Let's say f of x equals the square root of x. In this case, f of x plus h will be equal to the square root of x plus h. Let's go ahead and substitute the square root of x and the square root of x plus h to the formula. The derivative will be equal to the limit as h approaches 0 of the square root of x plus h minus the given function, which is the square root of x divided by h. What we're gonna do next is to multiply this with the conjugate of the numerator to get rid of the radical sign. We have square root of x plus h plus square root of x. Remember that the signs between these terms are opposite. This one is positive, while this one is negative. We also need to multiply to the denominator what we multiplied to the numerator. Square root of x plus h plus square root of x. It's like multiplying the formula with 1. The value doesn't change. Now let's apply the following method. The limit as h approaches 0, multiplying these two terms, we get square root of x plus h squared. Multiplying these terms, we get square root of x times square root of x plus h. Multiplying these two terms, we get minus square root of x times square root of x plus h. And these two terms, we get square root of x squared. On the bottom, we simply multiply h and the square root of x plus h plus square root of x. Notice that these two terms have the same value but with different signs. Now this will add up to 0, so we can cancel these terms. Now we have the limit as h approaches 0. The square and square root of these terms will cancel. The same goes with this term. We have x plus h minus x divided by h times square root of x plus h plus square root of x. X minus x is equal to 0, so we can cancel also these terms. Now h divided by h is 1. So we have the limit as h approaches 0 of 1 over square root of x plus h plus square root of x. To find the limit, let's substitute 0 to the variable h. 1 divided by square root of x plus 0 plus square root of x. The answer will be 1 divided by 2 square root of x. And this is the derivative of x squared. Let's have another example. What is f prime of x of f of x equals 3 divided by x? Go ahead and try to answer the problem. Now the function f of x plus h is 3 divided by x plus h. What you want to do next is to substitute 3 over x and 3 divided by x plus h to the formula. We have the limit as h approaches 0 of our f of x plus h is 3 over x plus h minus the given function 3 divided by x all over h. We need to eliminate x plus h in this term and x in this term. To do that, what you want to do is to multiply the top by x plus h times x. You should do the same to the bottom. X plus h times x. Now we have the limit as x approaches 0. Multiplying this term with x plus h and x, we can cancel x plus h, leaving behind 3x. Multiplying this term with x plus h and x, we can cancel x, leaving behind minus 3 times x plus h. On the bottom, we have h times x plus h times x. F prime of x should be equal to the limit as h approaches 0 of 3x. Distribute negative 3, we have minus 3x minus 3h all over h times x plus h times x. 3x minus 3x will add up to 0, leaving behind negative 3h on the top. The limit as h approaches 0 of negative 3h divided by h times x plus h times x. H over h is 1, so we can cancel this. Now let's apply direct substitution. We need to replace h with 0. We have negative 3 divided by x plus 0 times x. X plus 0 is x, then x times x is x squared. We have negative 3 divided by x squared, and this is the solution of the derivative of 3 divided by x using the limit process. Let's move on to our next example. Say a quadratic equation x squared plus 7x minus 11. How to find its derivative? Go ahead and figure out how to solve this equation. Now we're gonna replace variable x with x plus h to find f of x plus h. It should be equal to x plus h squared plus 7 times x plus h minus 11. Let's try to simplify this function. X plus h squared is equal to x squared plus 2hx plus h squared. 7 times x is 7x. 7 times h is 7h minus 11. Let's plug in these values to our formula. F prime of x will be the limit as h approaches 0 of, we have x squared plus 2hx plus h squared plus 7x plus 7h minus 11 minus our given function x squared plus 7x minus 11. Don't forget to distribute the negative sign in this term. X squared minus x squared will cancel. 7x minus 7x will cancel. Negative 11 minus negative 11 will become negative 11 plus 11. So we can cancel this. Then divided by h. Simplifying further, we get the limit as h approaches 0 of 2hx plus h squared plus 7h divided by h. Let's factor out h from the top. The limit as h approaches to 0 of h times 2hx divided by h is 2x plus h squared divided by h is h plus 7h divided by h is 7 all over h. The next process we're gonna do is to apply direct substitution. Let's replace variable h with 0. We have 2x plus 0 plus 7. Simplifying further, we get 2x plus 7. And this is the derivative of x squared plus 7x minus 11. That is how you find the derivative of a function using its definition. What you need to remember is the formula. However, using this process can be time-consuming, especially when it comes to complicated and complex functions. That's why we have different derived rules in differentiating a function. Stay tuned for more updates and see you in the next video.